Today we are welcoming Adam. Adam is a project manager of our Arlo backend team. Adam was with us for a little bit over a week. Actually, it's his last day here. And on his last day, he kindly agreed to give us a little talk. We already had a pleasure of hearing Adam's thoughts during the team leads meeting. It was very thought-provoking and interesting, and I really hope, I'm actually quite sure that it will be just equally interesting. Adam doesn't know how much you know about the topic, so if you guys feel like he needs to raise a bar or go lower, please do let him know. Yeah, just go with your questions along, right?
Sure.
And so, Adam, the floor is yours.
Okay.
We have about 1 hour.
Okay.
And,
yeah. No. Thank you guys. So first of all, it's been a great week working with all of you. I think I've really interfaced with almost everybody, whether it was in here on the basketball court or over beers or something. It's been great getting to meet you all and see you all in person, and I think the whole Arlo team is obviously very supportive of you guys, and I think you should feel there's a really good partnership between what the work that you do and what Arlo is delivering as a product. And so one of the things that I wanted to talk about today was picking a topic that has some relevance to how we think about the types of systems we're building at Arlo. Whether you're working on back-end, AI, xCloud, firmware, client, product marketing, ultimately what we as a company are delivering is a high-quality service, right? We have hardware, which is great, and high-quality hardware, and we're really a hardware company, but we are moving into a service-based model, right? Which means that as a company, we need to make sure that whatever we deliver in software services can scale and allow us to kind of move into a mode that we can just start adding more pieces to our offering with ease. And so one of the topics that I thought was important was talking about the concept of microservices, why they matter, what we are doing within Arlo as far as moving to kind of a microservice-oriented mindset. But I don't want it to be just about, okay, how do you go build microservices? I really want it to be practical, looking at what are the specific types of challenges, what are the specific types of environments that we have to be aware of, what is the impact on our product, and how do we go about as a team, again, building a system that is highly robust, highly scalable, and provides for our end users what we are saying we provide, which is peace of mind and connectedness, right, in the end. And rich set of features that make, if you have an Arlo system at home, make you feel safe, secure, and that you have a backing of our system that is going to take care of you when you're not at your home, or protecting you, that peace of mind feeling. So that's kind of the orientation of this talk. I really want it to be collaborative. I have slides. I'm not big on slides, generally speaking, but I really want to talk about how we can take a technical solution and make it applicable for Arlo, and really use this as a brainstorming session going forward. Okay. So I'm going to start a little high level, but let me know if you guys have any questions or anything you want to. I'm willing to kind of deviate the discussion whenever way it makes sense for us. Does anybody know what this is?
Microservices scale.
It is errors.
What's that? Errors, you said?
Errors, yeah.
Okay, possibly errors. Anybody else know? Anybody else? Something familiar to anybody?
Components of system.
I'll give you a hint. This is if I put another screen on top of this and put a brand name on it, you'd be like, oh, I get it. How many of you use Netflix? This is behind the scenes at Netflix. Okay, so Netflix is one of the companies that has pioneered the growth and popularity of microservices as a company that went from renting discs to a pure service-based company. In order for them to accelerate and kind of change their business model, other than kind of putting everything in the cloud, they basically adopted a microservice model. And there's a lot of blogs out there that they've written and others have written why, why this has worked for them and what it has. But I mean, obviously, saying this is errors and stuff like that is actually a valid point, because think about now taking a singular application, like a monolithic application, and deploying and having to manage that and the challenges with that. Now taking it and say you have thousands and thousands of individual small services that are all directly or indirectly interconnected and have to communicate with each other, right? What does that impact on a development or operations team? It's huge, right? Now this didn't happen overnight. This didn't happen overnight, right? This is an evolution. And it's also an evolution of how their software engineering has changed, right? It's not one team or 3 teams just implementing and just building. There are multiple small teams that are building small parts of their application that allow them to hit different capabilities that either were not there before or allow each one to kind of have its own life or have its own scale or have its own database, and we'll talk about that in a bit. So, one thing to keep in mind, other than just the magnitude of this, is that when we throw the term microservices around, it's really in context, right? If you have one application that does one thing, is that a microservice? I would argue no. I would argue a microservice is only applicable in the context of many services, right? Because then it's the magnitude of what each thing does and how it interfaces in the grand scheme of things of your application or your product is key. Does that make sense? Any questions on that? So keep that in mind. So micro, I wanted, what's the difference between a micro and a macro service? Why micro? So when you think about microservices, think about them in plural and think about, it's not just one service that is doing something small. It's really one service that's doing something small in the context of many other services that are part of your ecosystem, okay? And again, the impact on what it means to development teams, on testing, on deployment, on stability, crazy, right? Suppose just a few of these go down, right? What is the impact on the application as a whole, as a user, as a Netflix user, right? If something goes down here, see this web of all this connectivity. Does that mean that all the things that are connected to it are down? Does that mean that, I've disabled a piece of functionality in my application, right? That may be valuable to users, right? And then the question would be, well, why didn't I just build it into one application to begin with? Maybe it's easier to manage that way, right? So these are all key things and wondering why we, moved to microservices. So keep scale in mind and keep the fact that microservices is really only as good as how you use it and how you've evolved your teams to kind of support it, right? And so this is, a good kind of a kind of an analogy, right? The world 300 million years ago, everything was connected, and now, everything is split apart, right? And you would argue, oh yeah, this makes sense now because our continents are shaped and we have everybody organized in different regions, and I know, Americans from Europeans, from Asians, and stuff like that. But first thing to show, it's an evolution. Takes time. It doesn't just happen overnight, and things kind of evolve for reasons. And whether it's with the earth and physical and natural effects, or whether it's with software or programs or applications that we're building or services that we're enabling, they evolve, and they evolve to this point. So that's how people kind of think of microservices. Okay, so this might be some stuff that you guys already know or maybe haven't known, but what are some of the key tenets or key principles behind microservices? First, I think, and most important, is decoupling. So moving to a microservice architecture or implementing one from scratch, one of the main reasons, or one of the things you really should keep consistent when implementing all your services is decoupling that service completely, right? So I should be able to throw a new service out there, and it should bring all the resources it needs to it. It shouldn't be dependent on another database. It shouldn't be dependent on another file system that another service is operating on. And opportunistically, it allows you, if you have your own, let's say, database for your service, that database can have, you don't care how other people are using that data. As long as, if you have a service, for example, that is like event driven, right? And you need to store those events. Well, one type of a database or storage engine is going to might be more desirable for you, whereas in a traditional view of software, if you have a monolithic application, everything would have to fit into one type of database. It's like, oh, we have a relational database, so everything has to fit into that, and I don't care what the application is. So decoupling is not only beneficial, but it's also critical to that, to the foundation of those microservices. Going back to that previous slide with the Netflix diagram, if I don't decouple and one database goes down, or multiple servers are interfacing with that database without any kind of interconnection, now I have a very coupled and limited system, and multiple things can be affecting that, right? And then it limits me from scaling. The other thing, and kind of what I was just saying, it also leverages you to have the benefits of the CAP theorem, right? Say, this particular application, the reason why I'm creating this as a new service, this business use case justifies me doing this, is because I can pick the right data store for that particular application, right? Is everybody familiar with the CAP theorem? Okay. So you're always trading off between consistency, availability, and partition tolerance when you're choosing a database. And the theorem basically says you can only get 2 of those 3, not all 3. And there are certain database vendors that are more in one of these overlaps than others, right? So is your service oriented around being transactional? Right, so you really care about being atomic. You really care about the consistency of the data, right? Strong consistency. You really care about that there's validity and integrity on the data that goes in there and stuff like that. You're going to be more in the consistency mode, right? Really, whatever you need to do. So maybe partition tolerance doesn't necessarily something you're going to optimize for, right? And you can do that with a microservice because you have single source of responsibility, single area of concern for that service, and you can choose the database that best fits that, right? So decoupling and leveraging things like CAP theorem really allow you to do that. And in this day and age, when our software and our applications or services that we're delivering are so complex and have so many parts, being able to decompose it or decouple it and take one specific thing, one piece of functionality, and really make it sharp is absolutely critical, right? And it really is the success or failure of, it could be the success or failure of your application itself. Single purpose and responsibility, right? So, kind of mentioned this. So, and I talk about this a little later too, but when you're choosing what to put in a microservice, it's really important that you maintain that it does one thing and one thing very well, okay? And this becomes really challenging when you have an existing monolith and you have to move to a microservice, you want to move to a microservice, and you think, oh, I'm just going to take this package of code because it just looks like it fits into something that can be contained, or it makes it easier for me as a developer to do into a microservice. But that may not be a single point of responsibility. So now you're interweaving multiple pieces of functionality into one application, one service, and you're really not getting the benefit of being decoupled, or it can scale on its own, right? You're still going to be limited. So that's a really key point as well. Localization and high cohesion. So this comes down to kind of here. So there's this discussion about, okay, if I have a monolithic application out there, right? Everybody understands what I mean by monolithic application. Yeah, one big application that just keeps growing over time, right? Traditional web applications. That, every time you touch it, you're worried about breaking something else, but it's one big binary, it takes a lot. A lot of times what ends up happening is you really don't have a microservice, you have what is more like a distributed monolith, right? And coming back to the single purpose and responsibility, that you're taking a piece of your monolith and you're just taking your monolith and just cutting it into parts. And that's not what you necessarily want to do. You really want to be dividing it based on where business value is and where you can localize functionality and have maximize cohesion, or maximize the ability for those services to be able to kind of expand on their own, and minimizing or kind of unifying the cohesion that you have amongst them. So you don't want to just take your monolith and split it up and just have just a monolith that looks like it's a distributed application. You really want to have the center of loose coupling, single purpose, and cohesion all being unified together in one place, the sweet spot. And that's really where the microservice architecture starts to shine. Any questions? So then out of that you have something like this, traditional monolithic application, right, where you know, you might have one binary that's deployed that has multiple pieces of functionality and a single database, right? And the challenge is here. This might just be more straightforward, but moving to here and say, okay, I'm going to extract out the key business capabilities. And in this case, okay, the login microservice, well, it doesn't even have a database, so maybe I don't even need it to have a dependency on that database being up or aware, and it can kind of be on its own and lightweight, and then I might have two other services that are doing specific business transactions, right? Like account microservice obviously might fit into a more of a relational database model that is transactional, whereas, you know, identity microservice in this particular case, you know, may not. Or if I have, you know, trended or analytic type data, you know, that might fit into a different type of a data store that also supports scale and partitioning and whatnot. Okay, so what are some of the misconceptions of microservices? And I don't think this is all of them, but I think we could all probably think of things that that are out there. So first thing, monoliths are bad. We need to get rid of them. It's like, you have a bright software engineer works on a team and says, you know, this monolith, it just takes me forever to build this. It takes us forever to deploy, to get these software releases out there because they're so heavy. Every time we do it, we break something. So we just need to get rid of our monoliths, and we just need to move to microservices, right? And I guess the implication there is that monoliths are bad and microservices are good, right? But that's not necessarily true. If you have a monolith that's operating perfectly fine, and it's just a challenge to development, you might want to tackle that a different way. Right? You might want to say, okay, we still need to support this monolith, and we should still invest in that. And maybe it's even more cost-effective to run the monolith. But other things that we do that are new or inventive, we might want to start, you know, going with this decoupled model of microservices. Does anybody have any experience on that? Like where, in practical use case where, you know, there's this mindset of, well, we just got to move away from the monolith?
It's always discussions.
It's always in discussions, right? So just keep that in mind. That's not necessarily a bad thing. Microservices are a functional decomposition of monoliths, right? I just talked about that a couple minutes ago. We're not just taking a monolith and going into the source code and saying, okay, this module or this package, this is going to be a microservice, or these two are going to be a microservice. No, it's not a technical decomposition. It's a business value-based decomposition, right? If we take Arlo, for example, right, we have a service that's operating really well right now, and it is scaling, and we can continue to scale it. But if we kind of move it to a microservice architecture, we have to think about where the impact is going to be. You know, what are the specific services that we need to scale more for business value, right? For example, we might need to say that our payment engine, right, because we're moving more into a subscription-based model or pushing more services, that may need to scale. Right? So maybe we pull that out, and if we can scale that, we can justify supporting more subscriptions per day, right? A higher rate of subscriptions, add-ons, and stuff like that. That's business value, right? So justifying that, all that effort to move it out and do something adds significant value on that front. There are cost-effective ways to deploy. Deploying microservices, so you have a monolith, okay, we have this deploy, we may have horizontally scaled, you know, it's running, it's a certain cost, it's great. Moving to microservices, is that necessarily going to make things cheaper just because the services themselves are smaller? Right? Go back to the Netflix model, right? How much complexity do you think is there in managing their service, right? Especially you might have services that are just out there that maybe nobody is actively using, or maybe they're not used as others, but they're still taking up infrastructure resources, right? Especially if they're not tuned or being monitored properly. Right? If you don't have hysteresis-based scaling on these types of things, you may not be able to do that. So it's not necessarily just more cost-effective, right? And from the development side as well, development and testing. Think about testers. Who are all the testers in the room? Gore, anybody else? Right? Think about the amount of complexity it's going to make on testing every release. Okay? Development is easier, therefore deployment is easier. Okay? Yeah, development may be easier, but that doesn't necessarily imply that deployment is necessarily easier. It may be easier to release the product, but deployment is a whole other thing, right? Because it's post-deployment, it's monitoring, it's making sure, you know, it's fault tolerant, and we'll talk about that too. To build a microservice, you need to start from scratch, right? So, you know, okay, you could have a monolith that does need to be tuned. You don't necessarily need to start from scratch. So you can look at things, again, tied to business value that you can pull out. And the last thing that I've heard sometimes is that, failures are automatically handled by the infrastructure. So this model that I moved to microservices, but the DevOps team, and whoever is monitoring this, the infrastructure will take care of it because I've got this really super duper API gateway. I've got monitoring turned on. I've got circuit breaking happening. It's just gonna take care of itself, right? Until the time when your service actually goes down and there's a cascading effect within your system. Questions, thoughts, opinions?
Can I ask a question on previous slide?
Yeah, sure.
How data flows here from, if you need to know from account microservice, is your identity logged in or not?
Oh, in this particular application?
Yeah.
Yeah, so that actually brings a good point. This was just a sample of simple microservice kind of showing that. In this case, even in the monolithic side, you don't really see the relationship whether they two talk to each other. But you could assume that these might have to talk to each other in this side, and maybe it's through RPC or just some kind of programmatic interface. Whereas here, you now have to have some kind of routing. If this guy needs to pull stuff from this service, particularly if he needs data from this database, right? Now you have to have like an interface between these two, whether it's REST or otherwise. And not only that, but they have to be aware of each other, right? Whereas here you don't have to worry about awareness. You're just saying, I've deployed this software and I can leverage this and I can write code to do that. Here, then you have a whole ecosystem of, not only routing and networking and all these types of things, but this service discovery tied to all that as well. So there is complexity, right, in that, and understanding should they be able to talk to each other or not, right? I might have built this microservice great, and make this one great, but if the end use case, again, the business value of whatever you're delivering, creates a bottleneck here or something that's not defined, you're going to have a problem, right?
I see.
Especially when you might even have two different teams implementing these, right? So again, I think you're unfolding some of the complexities that come into this. So just a little bit about some of the patterns. This is stuff you can find online too, but ways that you can kind of, along with your set, how do you get microservices to talk to each other? How do you kind of abstract certain services from others, right? In the Netflix example, not when you open up Netflix, not every one of those services is being hit by your application, right? A lot of those are more back end, or some of those might be more front-facing than others. So there's different strategies you can go about with building microservice. There's an aggregator or proxy, right? So you have one service sitting in front of another one that's kind of proxying for it, right? Kind of also servicing some of the traditional role of like an API gateway. Chain, so you might have multiple services, making calls throughout the chain. So, the login service might call this payment service might call some identity service, and then you're chaining a sequence of calls together through different services. Branching, so you might branch off and you might have concurrent calls. So if you really need to optimize some particular flow in your application, now you have multiple services that can do it, kind of like threading, you're making parallel calls to multiple microservices, multiple services, right? So you're doing service branching. Shared resources, so there are many cases where even though you are completely decoupled, you might have shared tenancy, right? So some tables, some parts of your file system, or whatever, are shared between two services. Again, you have to be very careful with that, but that is a possibility. Especially if you have common data that is shared between applications that makes sense to split the business logic, because one might have to scale more than another, but data access might be similar. But that is something to be very careful of, because you don't want to break the decoupling principle. You might have some that are messaging based, right? So, instead of building a message bus into your monolith, you might want to have that completely on its own as a service, because again, the characteristics of how that application should operate, scale, and be available might be totally different than a different type of application. And the last one is like event driven, right? So you have eventing based, similar to messaging, that you want to be able to handle those in a particular way. The other thing, and I haven't mentioned this yet, but one of the key benefits of microservices is that it's what's called, the architecture patterns are polyglot, meaning you can choose whatever stack supports your needs for that particular application. I might have one that's a Java service, I might have another one that's a Node.js service, I might have another one that is Python or Go, and again, you're choosing the stack that's applicable for that service, for that business need, right? What are you optimizing for, right? What are you building for? So, whereas if you have a monolith, you're tied to whatever the stack you've chosen. Any questions, thoughts?
But
Yes, sir.
That freedom of choosing the stack has a serious side effect that increases complexity of the whole system.
Exactly.
And then because even the common protocols or communication models may have kind of corner cases while working between Java and Python, or
Absolutely.
that,
Absolutely.
that may come as a result of that.
Exactly.
Even though as a bonus you can probably have different teams working on the service with their expertise in that.
Yep.
Maybe especially good in even in the models where the partner-based development goes, when one team builds one microservice and another.
Yeah. No, absolutely. Totally true. It is a trade-off, but in one way you're saying, man, if only we could write this particular application in like a data analytics application, if only I could write this in Python or R and, build up this service, I could leverage those libraries and do what I need to do effectively as opposed to having to write it in Java, right? Or, I have this really low latency requirement and I need things to run fast, closer to hardware, I want to write it in C, or I'm going to, maybe use Golang or something of that nature. You're going to, you have that option, but you're right, they have to be able to support that. Yeah.
So that should be a mindful choice. I mean, the idea is it is a good flexibility, and the choice should be based not on just because I can do this, I will write it in Python, right? Or
Exactly.
or whatever.
Exactly.
But that should be the real need, like
Yep.
performance or compatibility or.
Yep, exactly. What you're delivering out of it, whatever again, this business justification for it. What are you going to buy? What are you getting out of it? Has to justify it. Exactly. Exactly. You couldn't say it better. Data decoupling. So we talked a little bit about the theoretical side of data decoupling and choosing which you're optimizing for, but I want to show this is AWS's kind of catalog of different types of databases. It's not just Dynamo, it's not just RDS. So the cloud providers have actually moved in this direction as well to say, hey, wait, people are building microservice type architectures and they need different types of databases for the different needs that are available. Right, so they even have a catalog of things, right? They have their own document-based database, or you can use MongoDB. They have graph-based databases, right? If you're doing like social network graphing or any kind of other application, fraud detection is another good one. Ledgers, right? So Bitcoin and blockchain type applications. Simple key values, obviously Dynamo is going to be your multi-purpose application for that. You can still use relational, nothing wrong with relational, by the way. If anybody thinks that relational databases are out of style, that's totally untrue. And not only do they support the Amazon variants, but they support Oracle, MySQL, and whatnot. Okay, so just to show, I mean, building applications. Think about, wow, I want to have this particular data model. There's probably a data store out there already, even in the cloud, that can do it for you. Okay, so we talked a little bit about, what are some of the tenets around microservices. We talked about some of the pitfalls. We talked about misconceptions. Now, really where I think the juice of microservices comes in is in continuous deployment, right, or continuous delivery model. Because if you cannot build a microservice architecture, right, remember we're saying multiple microservices that can be pushed through a pipeline with ease, then you have then you're just adding more complexity to you, right? Because instead of just testing one application, okay, we can control one application or two, but now when you've got dozens, you can't manage those manually, right? You have to have an automated delivery process that not only takes it from code all the way to deployment, but automates all your testing, automates all your processes in between, automates the ability to do fault injection and be able to test that application against different sources and make sure, okay, if this service is not up, can my service still operate? Those all have to be automated, and continuous delivery is extremely important for that. So you need your CI/CD pipelines, which should be well-defined and well-oiled in order to be able to support a microservice architecture, right? Oftentimes thought, we get that for free. As developers, somebody think, oh, we should have that for free, and we delegate that to a DevOps person. And I would also argue here that these teams that are building microservices are often small teams, but they're multifunctional teams. That's where the role of DevOps really came from. It's a person who's got some operational expertise, but also can write code and be embedded with the team, so that they're taking it from a application to a deployment model, or to deployment. And oftentimes, if you look at, again, Netflix or some of these other companies that have microservices based architecture, these teams kind of form on their own, right? So somebody has an idea and says, oh, this would be a business value add, and they say, okay, go off and do it, and it's maybe 2 or 3 developers working together, but they have to sell it. They have to not only just write code and write tests and off we go. They actually have to find other teams to integrate with, right? People that will interface with their solution. They'll have to find DevOps and people to bring it to production. They'll have to be able to find people or work themselves to monitor the application, to make sure it's stable, right? So the role of a developer has actually changed a lot too in these teams. And I think that's actually a really positive thing in many ways. So smaller teams, but more multi-faceted teams. Okay? And then of course, with the delivery model comes this API gateway. So an API gateway, and you saw that in the diagram before, it's just a proxy that sits at the top, the ingress of your application, that can scale, and that supports the ability to say, okay, I've got 1,000 services underneath of it, each with a different context path or different reachability. But from my client side, I just have a single endpoint, right? So they come in and say, I need to hit this particular API or whatever. They're service agnostic for the most part. So the API gateway is what's doing the routing to those individual applications. And also could be interfaced, it could be serving purposes like service discovery as well. It might interface with service discovery, saying, hey, if that service is not up, do I want to even start this chain of events or not? Okay. All right, impact on scale. So there are really 3 types of scale you have to take care of, and this is not true of just microservices, it's true of any application, but in microservices, say, as part of what I'm designing for, how is this particular application supposed to scale? Right? I think horizontal scaling is almost obvious. Right? You have to be able to scale horizontally, which is basically just saying throwing more instances of your application up, and there should be scaling to support a load and ramp down when the load goes down. But you also might have a case where you have to vertically scale your application. Right? There might be some functional decomposition or that you have to scale, or you might have resources that you have to add for your particular application. Right? So keeping that in mind, and then the other one is obviously data partitioning. Your application is native to a type of database that supports sharding, you might have to partition your database. If you're supporting a user database across the entire world, right? Your application obviously should support sharding and being close, kind of targeted to your users in a particular reason to minimize latency and access. So scale is also a very key factor when building microservices, and you have more control over how you're going to scale. With a monolith, you really aren't. I mean, actually, with a monolith, you're trying to solve everything in one. But here, you can kind of optimize for that. All right, and then the next topic is on service discovery. So this is kind of a detail, but an important one with microservices. That with those million or thousands and thousands of services that you have, like in the Netflix model, how do they all talk to each other? Right? If I just launch a new service, if I just drop in a new service tomorrow, how are other services going to be able to discover that and maintain that? If that service goes up and down or moves around or is dynamic, how do I have a common registry that can kind of keep track of where those services are, right? They might be in a different cluster, they might be in a different region, they might have gone down, or whatever the situation is, because a lot of times microservices are also very much tied to ephemeral environments like containers and non-persistent like physical resources. So you have to kind of the endpoints may be dynamic, and so service registry allows you to do that and say if service A has to talk to service B, he has a common bus that he goes to say, hey, service B been up, where is he? How do I reach him? Okay, so it's a very important part, and there's different types of patterns. There's server-side discovery, there's client-side discovery patterns that can be implemented accordingly. So just to be aware of that, I mean, this is all part of, as a development team owning the software stack, you have to also understand how your service is going to be used, how it's going to interoperate, right? So these are, again, some DevOps type functionality that you have to be aware of. Questions? Thoughts? Yeah.
I have a thought on that. So in terms of like high availability and redundancy, that should also, that pattern is normally used, right?
Absolutely, exactly. Yep.
Because if you want to put it in a different different zones and keep one zone as a backup for the primary zone,
That's
then
right.
if one zone fails, just that will be the quick switch in this discovery service.
Yeah, exactly.
Registry.
Yep, absolutely. And again, I can't stress enough, one of the keys to the success of microservices is how well you handle failure, right? You know, you can't just have this mindset, okay, if my service fails, it's okay. The person calling it will take care of it.
Mm-hmm.
You know, it doesn't work that way. You have to be able to either sustain failure, or you have to be able to kind of, I don't want to say predict failure, but you have to kind of have things in place so that you do not set off a cascading set of events, failures, right? It's very easy to do that with a microservice if the interoperability, interconnectedness is not well tested or even architected.
I have one question regarding service registry, discovery.
Yep.
It also should be scale.
Of course.
Yeah.
Of course.
It's also has. It depends on how many microservices you have,
Right.
and there is a limit.
Sure.
Probably.
Of course. Of course.
And if you have a lot,
Yep.
huge, few millions,
Yep.
it can bring. So all benefits from microservices can be removed, because you have to scale service registry with big amount of instances.
Absolutely. No, for sure. And I think if you look at some of the main vendors that do service registry, whether it's like Zookeeper or others, or like even Nginx that does kind of API gateway functionality, the reason those functions have been moved out, moved out of within the service or whatever, is because of things like that. They can scale and support high load, right? And they will auto scale based on, basically they have one role, right? Is to not allow the whole web to go down, right? Or, so of course availability is there, and of course there's going to be limitations. It doesn't mean that you don't have limitations, but then you think about how that gets architected. But yeah, agreed. Okay, and last, I don't know, a couple more. Any questions? I just feel like need a stretch or. What is the impact on development teams, right? So I threw some things up here, but let's just do a brainstorming. What do you think could be some of the key impacts on development teams? Anybody? If I came in here tomorrow, or someone from Arlo came in here tomorrow and say, hey, everything that we have right now, great, forget about it, we're obsoleting it, we're giving you this whole new microservice backend architecture, and everything is a service. We have 100 services. We've gone from, a few services that we can manage, to, let's say, 100 services now.
A lot of communication needed.
What's that?
A lot of communication needed for teams to align the protocols.
That's right. And at what point does that model break, right? I mean, you have a test team, right? Now if we said to you, okay, by the way, to test your application, now you have to deal with 100 different teams.
Yeah. I mean, it will impact teams.
It'll impact teams, right?
Because it will increase communication.
Absolutely. It'll require increased communication, for sure. Absolutely. Yeah. What else? Anybody else? Ideas? Yes.
Sometimes we build real long chains, and this could be a problem because not often we can understand where is the problem in which chain.
Right, exactly. Key point, I think. Your name again? Vlad says, dealing with, chaining, right? So, you have all these services out there, great, but this service calls this service, and this guy thinks it's great to call this service, and by the way, he's going to call this service, I want to get this data, he's going to call this service, right? So for one simple transaction, you now maybe have 5 or 6 services that are being called. How do you isolate? How do you find issues? How do you debug that? How do you monitor that, right? How do you test for failures, right? If service 3 goes down, what do you do, right? How do you handle that? And there are many effective strategies on that, right? And there's a couple that I'll mention here, So your services have to be aware, and more importantly, with these teams talking to each other, they have to kind of decide this. And if I change my service and you're building your service and we're already working together, we're both changing at the same time, there has to be some agreement, right? Because otherwise we're going to hit a log jam. We're going to be like, okay, is mine compatible with yours now? Is your, you're gonna break compatibility. So you have to think about, okay, who's going to be responsible? Is it the consumer or is it the producer? Right? Is the producer responsible for compatibility in that, or consumer? And there's different trends of thought within the industry on that. Like Netflix alone, I think they want to move fast, so they put the responsibility on the consumer to handle these things. And who's consuming that service? Yeah, great. Any other things? Yes.
Deployment when services, it's not always easy, because sometimes you get a lot of chains or how they work before, and also some specific rules you should know to step up one service.
Right.
And
Right.
These rules could be very a lot, and sometimes we can step up full system because
Some services are down. Yeah. So another good point is saying, deployment is not easy. I think we mentioned that a little bit. Is that if I have multiple services that have to be up, and each one has its own config, it has its own, again, different environment. How do we maintain that? Now, again, hopefully CD is doing a lot of that for you, and I hope a lot of it's automated. But as somebody who's building or testing that application has to be aware of that, right? Or what the rules are. So again, as a developer, you're owning more of that level of responsibility across the board to support your application.
First, to have more skilled programmers, developers.
You need to have more skilled programmers and developers. Okay, expand on that. What do you mean by that?
When moving to microservices, every developer should account in some area and should understand what he do, how to deliver it. But in general, microservices, it's not easy to understand the whole model of application.
Right. So each individual has more responsibility and understanding, and so they have to be more skilled. That's right. So Sergey is I think volunteering to train the team on these things.
One more comment.
Yeah, sure. Go ahead.
So I just think about you repeatedly say if service will down, and when we are going from monolith, when things are easily navigable, we can find logs easily and triage something.
Right.
On this model, when there is a network of services, it's hard to do the same things, and we should move to another understanding of if. We should think when service will down, because every service will down eventually.
Exactly.
It will happen.
Yep.
100%. And we should think about that not if, but when, and also think more about fault tolerance.
Absolutely. And I think especially when you're working in the cloud, and there's been so much tooling and whatnot in the cloud now that allows you to maintain availability of your application, right? You can get 4 nines, 5 nines, whatever you want, but it all depends on the application. And so again, I think Netflix and others, I'm using Netflix as an example here because they kind of have a lot of good information on this, but they actually purposely inject faults into their running application, so that they can see how not only things perform under failure, but they can also kind of allow their services that have been designed that way to operate in that way, right? So that they can kind of do their own throttling and do their own limiting, and seeing that the things that they were designed to do are operating that way. So fault tolerance and fault injection are actually more important than just a load test, right? It's actually part of your practical use day in, day out. Yeah, good point. Yeah. Anything else?
I think they are using this framework called House Monkey, which randomly shuts down one of the services in a mesh, and then the rest of the system needs to regroup and and be sustainable.
Right, because they need to exercise that functionality. It's kind of like it's like keeping your car in the garage, right? Car stays fresh, but if the car doesn't move, it doesn't get used, and you can't break it in and test its functionality to see that it works, right? Anything else?
We should have effective protocol to minimize latency and traffic.
Correct. Yeah, I mean, traditional REST or HTTP, that's not going to work
Yeah.
for all of these services, right? Because you're adding a lot of overhead. So if you take a monolithic application where you have very fast communication between threads and whatnot, and now you go to multiple services that have to talk to each other, and you're adding HTTP overhead or whatever else, of course, not only is that more bandwidth and throughput, but that's also more latent. So you're right. You have to think about what the endpoint that you're designing. What is its targeted use case? What is the best way for it to communicate with it, discover it, all these types of things, and then be able to, still meet the same requirements that you would have if you implement it as a monolith. So yeah, very, very key point.
So in generally, monolithic applications would be considered as more as having a better performance compared to the microservices.
Well, it depends. I mean, in certain ways, right? So for making one procedure call to another, absolutely, right? But within the container, right? Like especially if you're talking about the JVM. But if you're saying now that a monolith, that might be a memory-heavy application. It's not going to be necessarily. It may not be optimized for efficient use of those resources, right? Or maybe it's a CPU-bound application because you have so much going on, so many processor and threads are running within it that is inhibiting its ability to grow more, and that's why you want to move it. So yeah, I mean it's true. It could be either, but yes, performance. I think performance is easier to conceptualize in a monolith and fix or change, but not necessarily so in microservices. Okay, this from Google. 70% of the outages that are in production systems are caused by changes to a live system. 70% of the outages are caused by changes. Right? So, okay, in a monolith, how frequently are you deploying? Depends, right?
Ideally, once a month.
And it's less time. I mean, you could be doing daily, whatever, but most likely not, right? Because the overhead to build and deploy a monolith is usually a lot heavier. Okay, so what about a microservice architecture? Not just a service, but let's say I have 100 services. How frequently am I deploying? In general, to this ecosystem, right? To that web. Go back to the Netflix web. How often do you think they're deploying?
Can be every day.
Could be every day. You might have. What if 30% of your services are changing every day, right? As a service, right? I'm a Netflix user. I don't care if there's a monolith behind there or 100 services, but that thing better work, right? So, if this is true, what does that mean about moving to a microservice model?
70% more chance.
Right. Yeah, exactly, right? It's a lot more possible to fail frequently.
Now every day, not every day.
Yeah, every day, right? we have a hard enough problem keeping our own system up every day, let alone now saying I have 100 hands in the picture, right? So here's some strategies for dealing with self-healing. Right? As a microservice, building that microservice, okay, as a developer for this microservice, I think Sergey, you alluded to this a little bit, you have to be more aware of a lot of things. You have to say, okay, I have to predict all the types of error scenarios and be able to heal not only my application, but I also have to kind of be preventive, right? It's like, building a fence around your house, right? You have to say, who am I going to let in? How am I going to let them in? What, and what load? Rate limiting, right? I might say, we've designed this application to only support, this throughput, whatever it may be, right? And I should be able to limit everything else. And the back pressure will feed its way back through the application or rerouting accordingly, right? So that you are maintaining the SLA of your microservice itself, right? Fail fast, right? So it's another key thing. If you're deploying a microservice and it's just sitting there, and it's like, it's 20% up and it's just waiting because it needs 10 other services to be up, and it's just waiting and it waits 10 minutes, it waits, that service is not up, right? So think about fail fast. Okay, if things are not up, minimize your dependencies, but also what if it's not up, fail fast, acknowledge it, and really have that monitoring feedback loop immediate. Avoiding single points of failure, I mean, that's true in general, right? So thinking not just your application, but thinking about what's in front of it, load balancer, if you have an API gateway, all these things have to be thought about so there's no single point of failure. DNS, networking, right? It's more critical to even know what the networking rules are for your application so that you can make sure that's not a single point of failure as opposed to just delegating that to somebody else. And circuit breaking, right, which is a key thing. So again, coming back to this whole concept of cascading failures, right? I'm as a service, there might be multiple services that I have to talk to, and if I have to talk to them and I have a failure and I introduce a failure here and a failure there, right? If they're not robust enough, and these all start creating a cascading chain of events that causes a dramatic effect, instead of having that happen, you might want to have monitoring in place that has a hysteresis that say, open a circuit breaker, right? So basically, these services that are talking to each other, you flip the circuit breaker, and then these two can no longer talk to each other. You're kind of stopping it either in that particular transaction or just for the flow of those services together to be able to do that, right? So tripping that circuit breaker and then closing that circuit breaker when things return to normal, right? Or then you have this half-open stage as well. And this is kind of kind of what that might look like. And there are plenty of effective ways of doing circuit breaking and different tools that are out there to support that. But this is also very much important when you're testing and building and deploying these applications. Have you defined your circuit breaking rules effectively, right? So that you're kind of holding the system up all the time and tripping things when they don't work, right? In your house, your circuit breaker trips when there's some issue in power, right? So just cutting off the current from here to here, or turning it off completely, so that no further adverse effects happen. All right, so conclusion. In a nutshell, microservices are a compelling architecture, right? They are valuable if you decompose based on business value and iterate over that, meaning you deploy microservices, in a way that you're delivering something key to your end users. It supports asymmetric data flows, right? So you don't have to have all your data flowing through one application. You can have a service to say, this is a high throughput service. Target all your throughput through that particular service or set of services. Rapid development iteration, so if it's just 3 of us working on this one service, we can actually iterate a lot faster. We can add more features, we can tune things, we can even refactor, rewrite if we need to, faster, right? That's a positive. And decoupling, right? Said, we don't really like Dynamo. It doesn't work well for this application. We want to go use Neptune or one of these graph databases because for this particular service that would work better. You can do that and should. However, right, using it just to simply take a monolith and convert it over may not be effective, right? I think it's obvious by now why it may not be effective. Don't just take that monolith. And I think that's just not a mindset in design. It's also a mindset when you're writing code, when you're testing, right? Thinking about that. It's not like, is this really a value because of all the things we just talked about with the impact? Deployment support, CI/CD monitoring, these circuit breaking rules are all critical. Failures must be embedded within the application, or handling failures, must be embedded within the application. Don't rely on the container and the infrastructure to handle failures for you. Just because you're working on AWS and they have HA doesn't necessarily mean that your application will be sustained from failure, right? Or the flow of that application. And be mindful that the team as a whole owns the full vertical of that application. Right? It's not just you as a developer committing code and then going on to the next thing. You really got to help that service along all the way. It's your baby. Okay? So hope that was just about the right amount of time for everybody. Is any questions, thoughts, Kate?
Okay, so you mentioned that you decided to create some application, for example, online shop.
Yeah.
And you have small amount of money, and you have a small team, and you know that it would be great to make microservices, but as you said, it's very hard to create all this CI/CD stuff, to make it fail safe, to make all these protocols and so on. You need to make this product very fast, and go to market as soon as possible. So what do you will decide to make monoliths or microservices?
That's a good question. I mean, so I think what you're tapping into is this idea that, oh, microservices sounds cool, right? But I don't have the resources to do it, right? Or I don't even have the expertise to do it. But I think what you should be saying to yourself is, okay, what are we trying to deliver in business value? Right? What is the most important business value you're trying to deliver? Right? And in that application, maybe, for example, you're just trying to reach users. Right? Maybe, maybe you're not going to have many sales yet, but you're trying to reach users, right? So you might have one service that says, okay, this is just going to be targeted at reaching users, engagement, that type of thing, right? And so that will allow you to do two things. It'll allow you to quickly iterate and get something out there, and also decouple the key value parts of your application from things that are maybe on the back burner, right? Now, for the rest of your application, you might say, okay, maybe we started as a monolith. Because again, maybe that application will grow, maybe it won't, but if it's easier to deploy that, again, business value is something that is a monolith, do it, right? And as your needs start to come into place, where you say, man, this monolith is no longer scaling, then you can start to think about how to decompose it. Right? So it might sound reactive, but for that particular use case where you're saying, well, I need to get something out there and I have such expertise and I can't spend this amount of time just architecting something that is so expansive, sure, you can do that.
So it means that this typical situation when companies have their monoliths that they want to divide to split in microservices, it's typical situation and it's normal.
Yeah, absolutely. I mean, so there's two things on that, right? There's a lot of things where applications, microservices is not necessarily new, but it's also not old either, right? So there's a lot of, and most applications today have some legacy component to it, things that have grown over time. So yeah, a lot of companies are going through that, oh, how should I split my monolith? Because they've hit a point where they do it. So it's not bad, right? That's why I'm saying splitting the monolith is bad. It's just why you're choosing to do it now and for what reasons you're doing it, and making sure that your architecture that comes out of that matches that, right? And you're not just splitting things because you think that it looks better from a deployment footprint to have it that way. It's trade-offs all the time. So trade-off on things that you think are going to be of value, not of things that you think are valuable. Is there a question? Sure. Any other questions? Good question.
It's obvious to have a team of parallel architects.
Is it what?
Is it required to have a team with parallel architects?
Sure. Sure. I think you should. Yeah. I mean, whether you're doing microservices or not, I think that's a good idea. But especially here, because having oversight amongst an entire ecosystem is, I think, key. And having folks that spend their days thinking about where these things are going to fail, where the interaction is going to fail, how do we innovate and create solutions that keep our system as a whole up. Yeah, for sure. I think I was saying this yesterday. All the major companies do that, right? Amazon has a whole team of just people that are like, brainiacs that sit in a room and are, looking to poke the system all the time and find ways to make things better because they have a huge responsibility to handle. Right? But yeah, of course. Any other questions, thoughts, ideas? Anybody using microservices like actively or either work or home or otherwise? Anybody think that microservices are just equivalent to APIs?
I think that microservices is okay, but we should think about serverless.
Yeah, I was going to mention that too. Yeah, I mean, serverless is obviously it's a great way to kind of take a step into microservices because it's minimal investment and rapid development. And then again, from a business model, you will also fail fast there too, right? Say, does this work or not? Okay, we can scrap it, right? So serverless models in any cloud platform, AWS, GCP, Azure, whatever, are a great way to do that. And it's great for entrepreneurs. That's what, if you want to do that, if you want to build an application, go serverless and try it out. And, at least with AWS, I think the others too, you're paying only for hits, not not consumption. So if your cost is high, then it's a good sign for your
It's
business.
interesting here that we didn't mention one important thing, that QA needs.
Sorry?
QA needs.
QA needs, yeah.
So if we have many components in one system,
Yeah.
it's more hard for them to test that. So
Right.
they need some efforts to test it in isolation.
Right.
There are, of course, tools and even frameworks for that.
Yeah.
But before that, before microservices, probably they could do their work themselves.
Absolutely. And I would argue that, similar to, testers need to be fully embedded into the microservice team. And they should be testing the context of that microservice alone, right? End-to-end testing might be a little bit more outside that reach. So you might just have end-to-end testing, but really the key part of it is make sure that microservice is fully hardened to be able to support anything that comes its way, right? When it's in the mix. Yeah, so absolutely, yeah, testing for sure. Anybody else? Any key takeaways that I missed? Anything any other topics that you think are good derivatives from this that you would like to learn about?
I have one additional point about prevention failures.
Yes.
It's blue-green deployment.
Oh yeah, it's a good point. We didn't talk about that. I also didn't talk about containerization much and all that kind of stuff. That all comes for free, absolutely. Blue-green deployments, canary testing, deployments, you absolutely want to do that. A/B testing.
Yeah.
These are actually, and even having mix of environments, right? So canary testing is saying, we want to roll out this new feature or new service, right? And the other services, may have to discover that. So you roll it out to 5%, 10%, get feedback. If it's good, keep it. Otherwise, roll it back. But yeah, that works along. That's really side by side with your availability requirements, right? You're not just saying throw out a new service and then, like you were saying, you got to deploy the whole stack now. Every subsystem has to upgrade. You can't do that, right? You can't do that with 1,000 services. So, having that, and when you're canarying and you have multiple versions running at the same time, you're getting that natural mix of versions that can test together, interoperability. Yeah, good point. Really good point. Any other questions? Yeah, Andre.
In my my takeaway, I think I would like to share is that the microservices themselves give great opportunity to create highly scalable and available applications.
Yep.
That's good for large systems that might grow extensively.
Mm-hmm.
And but when thinking about choosing between the microservices and monolithic, then there are important factors that have to be considered, like increased complexity, not only in development but also in QA.
Yep.
In deployment, it requires it demands intensive automation.
Yes.
In most of the things.
Yeah.
While when you deal with monolithic, you can keep doing something manual, right? You can deploy manual,
Yeah.
you can
You can
test
too.
manual. You can make it simple.
Yeah.
And
True.
with microservices, like that, raises a bar for the infrastructure of the whole development process.
Totally.
And but yeah, then it gives then it will give this benefit.
Absolutely. Yeah. Very, very much. Very true. Yeah. So just to wrap up here, bring it back to Arlo, right? Where it's important. Or, there's probably some Netgear folks in here too, or others. But in general, I think it applies. Just keep in mind as we start to move to, as a company, being more service-minded, not just hardware and all this kind of stuff. Keep in mind that we have to expand our offering and our capabilities. Microservices might be one of the ways, or is one of the ways we're looking at doing that. Doesn't mean that it's going to be a complete switch over, but there will be new services that are out there that we're deploying that are going to serve certain things, and the ramifications across engineering in general, or testing, or product, are, you know, some of the things we talked about here, and probably many other things you can think of as well. So just keep those in mind. It's one of the reasons I wanted to present this and talk about it. So keep the thoughts going, and thank you guys again. Appreciate it. If you have any other questions, let me know anytime. Questions?
So do you use microservices or monolith application in Arlo?
Yeah. So we are. So we have